Starting now. Okay, so starting with the first one, it's quizzes. And let me pull this up. So quizzes, types of solutions. So these are the types of questions you're going to see. Like you're going to look at a graph and you're going to figure out how many solutions are there. Okay, if a graph doesn't cross, what kind of solution do you have? Okay, there you go. If it does cross, how many solutions we got? One solution. Okay, if they're both right on top of each other, right, you got an infinite amount of solutions. Okay, so that's the quizzes. So that shouldn't take too long. Then you got your IXL, like I was telling you guys about. So again, just come in here and click on this link. It should take you right to the assignment. Let's just actually, I'm going to sign out, just give you guys an example of what would happen if you're not signed in. So again, click on it up here, or actually sometimes this will pop up too to make sure that you're signed in. So make sure you're signed in. If you don't, it might look like this up here as well. So, and click, use the saving feature for Google so that, you don't have to remember your information every time. So you can see level J, AA, 0.4. Okay, that's what it says right here. So it matches up. I'm in the right assignment. Now, what you want to do here is you're going to graph these equations. You're going to graph them and then basically answer the same question like you do in the quizzes. All right, so here I'd start with, now when you graph these, you basically are going to graph one at a time. So for the first equation, the button's down here. Make sure it's whatever button you're clicked on, that's the one you graph. Okay, so I'm going to start with 2x minus 2. So start at minus 2. The slope is up 2 over 1. Now to graph the second equation, you got to click on the button to switch over. So that's what's different from delta math. Delta math lets you just do them all without having to click a button. IXL, you guys need to click that before you do the next one, okay? So the next one is -1, but it's the same slope, up 2 over 1. Yeah, and look, they're not intersecting, right? They're not crossing, they're not touching. So here, you'd select no solution, okay? Also, you can click on this. It'll read it out to you. It'll tell you,
many solutions.
It'll read out all of those in case you need to hear what they sound like for you guys that are, working on your English. Okay, so here, again, I start at 1 for the first equation, and then I go up 2 over 5. Then I'll click on the second one down here, and I'll start the second equation, start at -2, and the slope is 1, so I go up 1 over 1, and then there's my solution where it crosses. Okay, but I'm not actually saying what the solution is. I'm just answering the question, what kind of solution do we get? In this case, it's just 1. Okay, so that's really the focus of today's assignments, is what kind of solutions are you getting? Not really what is the answer, but like what kind of answer. What's that?
What was the required score in that one?
And you'll see it's right here. 50 points. So look right next to the assignment. Somebody asked in class, what's the required score? Make sure you're looking right there. Okay, it'll be right next to this link. That's where you'll see the required score. Okay, so the next one. Okay, so now you don't have a graph. You're just looking at the equations. Okay, and we'll talk about how to figure these out here in the notes. Okay, we'll take some notes on how to figure those out. Okay, and you'll see that in the ed puzzle as well. Okay, but basically just by looking at the equation and the slope and the y-intercept or the b's, you can figure out how many solutions it has. Also, just so you know, if you see this up here in IXL, you can click Learn with an Example. It's kind of like Delta Math where it shows you an example. It'll help you kind of explain how this works. Okay, so that's another option if you guys need some help. And just click on it again and it'll take you back to the problem. Okay, so we'll go over how to answer those here in a second. Okay, then after that is a worksheet. Okay, where you're given some equations and your job is to figure out, is it going to be no solution, infinitely many, or one solution? So the same type of question. Okay. This one we're not going to graph. This one we're actually going to do the first steps in the equation by substitution or elimination, and then you'll be able to figure that out just by doing one step, okay? And I'll show you guys that here in a moment. Okay, then obviously there's a quiz at the end. Okay, then these next three folders are all about triangles and transformations. Triangles, what types of triangles? So if you guys remember from middle school, like scalene triangles, right triangles, obtuse, acute, it's just going to talk about that and the triangle sum theorem, which we'll go over. We're going to go over that today as well. And then the rest of the week is transformations. And transformations are basically like you have an object and you're moving it. And you're moving it different ways, okay? So for instance, let's look at the quizzes, for instance, for this example. So you have different types of movements of shapes. So like if I move something like this, for instance, so this shape, it moved from the right to the left, that means I'm flipping this shape, right? Or is this one, here I'm kind of rotating or I'm turning the shape, okay? So basically you guys are just gonna be learning what those are called. What's the name of them? And then like, if I give you a picture like this, what type of transformation is it, okay? So that's what Thursday is all about. And then the last one is dilations. Dilations, which basically means either you're starting with something small and you're making it bigger, or you're starting with something big and making it smaller. And if you think what the word dilate means, have you guys ever heard of the word dilate, like with your eyes, right? The pupil in your eyes, it dilates, it gets bigger and gets smaller. That's kind of like where that word comes from, okay? So that's what this week is all about. All right, so you actually won't have a lot of solving this week. Not a lot of solving equations. Okay, more so geometry, if you guys remember geometry. All right, so we're gonna take some notes. So let me pull up in the dot cam. Share up a different screen. So if you guys are home, make sure you have your notebooks ready. You guys here in class also the same, have your notebooks ready. Oh, you know what? Let me do a different type of screen here real quick so I can flip back and forth. Get rid of this. Close that. Oops. Okay. So here, I want that camera. All right, so let me share my screen again for you guys at home. Okay, so you're gonna wanna take out your notebook, open up a new page of notes. Let me pause the recording. So here I'd have one line and the other line is literally right on top. Okay, so I guess I'm gonna color all these. The separate lines. Oops, I keep grabbing the wrong marker. Okay, this is where we have infinite solutions. And infinite, if you guys know the word infinity, just means forever, right? So if you have infinite solutions, that means you just have many, 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 many different answers. Okay, you can have as many answers as you want, basically. Any answer would work for X and for Y. Okay, so this is if you're just looking at a graph. If we give you a graph, boom, you can see it right away, right? But what if you just have an equation? Okay, then that's what the worksheet is about today. All right, so we're gonna go over some examples. We'll put over here looking at graphs. And then we'll go over some examples of how to figure this out with equations, okay? Okay, so the first example we'll look at is y equals 4x minus 6, and then x minus y equals negative 9. Okay. So remember, the goal here isn't necessarily to like find what the answer is, but what kind of answer are you going to have? What type of solution? Okay, so if you guys remember from before, from the notes before, we have one equation that's in y equals mx plus b, or y equals, and the other equation has x, y equals a number. So you have one that's in slope-intercept form, and then one that's in standard form. Okay, if we go back to our notes here, remember when we had it like this for elimination, x, y, and then a number, that was standard form. Okay, and then before that, we had solved by substitution where we had one equation that was y equals. And we took that part of it and plugged it in, okay, and then we solved for one variable at a time. Okay, same thing down here. Here it's equal to x, so I took that part, plugged it in, okay, and then we solved for an answer. Okay, so this situation, we've got one equation with y equals. So one equation has y equals. So this means we're going to do substitution. Substitution. Okay, so now this part to the right, that equals y. So that's where we're going to plug it in. We're going to plug it in right here to y. So now we have x minus, I'll put parentheses there, and then the 4x minus 6. Now you got to remember that there's actually a number right here in front of that y. We have a 1. So I'm actually write that in here because we have to distribute and multiply that negative 1. So now I'm going to multiply negative 1 here. So negative 1 times 4x is minus 4x. Negative 1 times minus 6, that's plus 6, equals 9. Okay. Okay, now we want to combine like terms. Okay, so these are like terms, so we'll combine those. So remember, this is basically 1 here. So 1 minus 4 is minus 3x. Oh, I forgot my line here. Sorry about that. And then plus 6 equals negative 9. Okay, then we'll subtract the 6 from both sides. That cancels. We have minus 3x equals, we have we're adding 2 negatives, so we add them. And we get negative 15. And then the last step here is to divide by minus 3, or negative 3. So x equals 5. Now, you have an answer. You have x. So what that means is that you're going to have a solution. You're going to have one solution. Once I have already figured out in just doing that first step, like right now, the question's not asking me to find y, x and y. It's just asking me what type of solution. Okay, and when you guys do the worksheet, that's what it's asking for. What type of solution? So as I'm working through this, I get x equals 5. That means I'm going to plug in the 5 and I'll find y and I'll get one answer. Okay, so here in this case, I would have one solution. So that's the main thing I was looking for, is I got one solution. Now, if you're doing substitution, that's usually going to take a little longer. If you're doing elimination, it's going to take a little less time. Okay. All right, so now we're going to do one more like that. Okay, if you have room here, go ahead and put it there. If you got to go down below it, that's fine. Okay, so we're going to do one that's very similar. We're going to do negative 4x plus 7, and then 8x plus 2y equals 17. Okay, now again, same approach, same thing. This, we got y equals, I'm going to take this and plug it into y. I plug in the negative 4x plus 7 again. And again, same steps, we're going to distribute. So I just bring this 8x down. 2 times minus 4x is minus 8x. 2 times 7, 14, equals 17. Again, same steps as before, combine like terms. Notice what happens in this problem. 8 minus 8x minus 8x, that's 0. So these pretty much cancel out. All I have left is 14 equals 17. Right, so there's no more variables to solve for. If there's nothing to solve for, then that's it. But you have to look at the answer. Do these numbers actually equal each other? Obviously, no, they don't. 14 doesn't equal 17. Like Marshall said in here, no solution.
So then they have to.
If they equal, that would be the other situation, infinite.
Oh, yeah.
So if they're equal, then it's going to be infinite solutions. Okay. Okay, I'm going to put this next one right below, down here. If you got to, again, if you got to go to the next page, go to the next page. Okay, so now both of these problems are going to be in standard form. So I have negative 3x plus 4y equals 5. Right below that, plus 3x minus 4y equals 3. Okay. Well, notice right at the bat, they're both in standard form, so we could try elimination. We need opposites. We have negative 3, positive 3, cancels. Positive 4, negative 4, cancels. So that means on the left side of your equation, you have 0 because you have nothing left. So 0 is nothing. But on the right, we have 5 plus 3. So 0 equals 8. Same thing like this problem, no solution. Again, if the numbers are not equal, it's no solution. Okay, let's look at one more like that example. Okay, I'm literally going to take the same problem, at least the x and y part of it, and then we're going to have 5 here, and then we'll have the same numbers on the left. Just the only one we're going to change is this one right here. We're going to put negative 5. Daniel, where's your notebook? Get your notes out. Okay, so now same thing. Opposites cancel, and 5 minus 5 cancels. They all cancel. So now this time I've got 0 equals 0. But the only difference this time between the last two problems is that 0 does equal 0. 0 is actually a true statement. So if it's true, that means you're going to have, but again, it's true, but you have no variable. You didn't like get an answer. You didn't get y equals 3 or x equals 5. So here we're going to have infinite solutions. So that's how you can recognize it right away. And you notice that these two problems, you recognize it like right in the first step. Like cancel, boom, it's 0. Here's a different number, no solution. Here they all canceled. I know it's going to be infinite solution. Okay, so here on the side, I'm going to put example. Let's say x equals a number or y equals a number. You're going to have one solution. If you have, let's say 5 equals 3 or 0 equals 10, okay? In other words, it's not true. That's going to be no solution. Okay, and then the last case would be like the numbers do equal. So like 5 equals 5, 0 equals 0. If it is true, then we're going to get this case, infinite solutions. Okay, I'm going to pause the recording, give you guys a chance to catch. Okay, and remember, you guys can always go back over this. I'll post this as soon as we're done. I'll post it on the School of You site. Okay, if you didn't get it. So, or if you missed something. Okay, so day 2, triangles. Okay, now the first part of day 2 is going to be like different types of triangles. It's going to talk about like acute triangles, and we'll just make a note of them up here. Oh, wait, you know what? Actually, I'm going to want kind of notes on the side here, like Cornell notes. Okay, so the first part will be different types: acute, obtuse, right triangles, etc., etc. Okay, you're going to learn about all those different types, and there's a few more, but I'm not going to kind of talk about too much about that because again, you guys are going to go over that later on. What I am going to go over is finding missing angles. So finding missing angles in a triangle. So for example, let's say I've got a triangle. And in one corner of the triangle, it's 20 degrees. And remember, the degrees is how you measure angles, right? The corner, how big a corner is in a triangle. Okay, in this corner, it's going to be 103 degrees, even though honestly, this doesn't look like 103, but sorry, my drawing's kind of bad. But honestly, that's not important. What's important is what is the number. Okay, and then over here, we're going to call this x because we don't know what it is. Now, if you guys remember, you remember how many degrees does the angles inside a triangle add up to? Not 190,
180.
180. So you're close. So remember, they all add up to 180. Okay, so if I know they add up to 180, I can take all of these, add them up, and they should equal 180, so I can make an equation. So that means that if I take x, or whatever that angle is, and add 20, and then add 103, that should equal 180. So now if you think about it, I just created an equation. We're just missing one number. So now we just solve it. So first, I'm going to combine like terms here. Combine those two. So I get 20 plus 103 is 123. And then subtract 123 from both sides. And x equals, what was that, 57? 57 degrees. And don't forget to put the little degree symbol up there, okay? So this is called the triangle sum theorem. Okay, and that's the title you'll see there in the Schoology when you guys get to that point. Okay, and then always just, again, make sure write degrees on your answer. And when I say degrees, what I mean is, like, for example, 49 degrees. Make sure you're putting that little symbol there. Okay, just like I put there. Okay, so we're gonna do one more example, last one. And you guys at home will be done. So another example just like that, again, just reminder, all angles add up to 180. So let's say I've got this triangle, and what I'm gonna do is I'm gonna name the corners. So I'm gonna name this A, B, and C, all right? So this corner is 60 degrees. This one is 48. And this one's not X, we're gonna call this one's actually 5X minus 3. So the angle.
We can't see anything. It's freezing.
Oh, my bad, guys.
Yeah, we can't see anything.
So 5X minus 3, that's the first angle, plus the second angle, plus the third angle. Those should all equal 180. Okay. Okay, follow the same steps as before. I want to combine like terms, but I want you to notice I've got 3 like terms this time. I've got -3, 60, and 48. Okay. So add that up however you want to. I'm going to start with the positive numbers. I'll go 60 plus 48. That's 108. And then -3. Actually, we'll do this one step at a time, just so you guys can kind of see what's going on. So this is basically going to add these two first. Okay. And now -3 and 108. Well, that would be 105. And now, just like before, subtract this term from this side. So minus 105 from both sides. I get 5X equals 75. And now this step, I've got one extra step. I got to divide by 5. And X equals 15. However, that is X. That's not the answer, because the angle is represented by 5 times X minus 3. So that means what I got to do is take this and actually plug it back into that expression to find the actual angle. Okay, so now angle A, we'll call it, equals 5 times, basically I got to plug in this 15. And then subtract 3. Okay, so 5 times 15, 75, minus 3 equals 72 degrees. Okay, so that missing angle is 72 degrees. Zoom out a little bit so you guys can all see that. You guys are kind of copying all that down. Okay, let me stop the recording because that's pretty much it for now.